Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who want to take up engineering in the future, and to your relatives. Now, if you like what I'm doing, if you find my videos interesting and important to your studies, also don't forget to subscribe. So this is Engineering in Progress 1.7. If the amount of light that can penetrate a depth of y meters in an ocean is given by 10 times quantity point 4 to the y, what is the amount of light at 2 meters and at 5 meters? So this is simply calculating this expression here. You may use your calculator, you may not. Actually, you may not. So amount of light that can penetrate the depth of 2 meters is substituted to the formula 10 times zero point 0.4 square. So 0.16 times 10 is 1.6. Then for the second part, amount of light that can penetrate a depth of 5 meters is 10 times zero point 0.4 to the 5. And that would be, so you may use your calculator or you may not, 32 over 5 to the 5th. So that would be 0.1024. If the half-life of a medical substance is 5 days, then the amount remaining after n days is approximately A sub O quantity times AO quantity K to the n. How much remains after 4 days in percent? So half-life is 5 days, so in 4 days, the amount remain in percent should be greater than 50%, where AO is the original amount. So let's call it R. R is AO quantity K to the N. Then R is zero point 0.5 of AO in 5 days. So zero point 0.5 AO equals AO times quantity K to the 5. Cancel out AO, so it raise everything to 1/5. So K is zero point 0.5 to the 1/5. Then that is the value of K. Substitute it here. So R equals AO quantity zero point 0.5 to the 1/5, then raised to n, and n this time is 4. So use your calculator to evaluate that. That's 0.5 to the 4/5, and 0.5 to the 4/5 is equal to 0.5743 of AO. Therefore, in percent, the amount that remains after 4 days is 57.43%, or 100% times 0.5743 AO divided by AO. So you cancel AO. So it is 57.43%. The amount of a drug in the body 3 hours after an initial dose of 60 milligrams is given by 60 times zero point 0.7 to the T. Estimate the amount of the drug in the body 12 hours after it is taken, and also 24 hours after. So it's a matter of substitution again. So amount of drug in the body is equal to 60 times zero point 0.7 to the T. So for the first part, T is 12, 60 times zero point 0.7 to the 12, and using the calculator, it is 0.38305. Then in the second part, 60 times zero point 0.7 to the 24, and therefore it is equal to 0.0115. For if the value of an investment in a rare coin increases at 10% per year, then its value 3 years after being purchased for P pesos is P times 1.1 to the T. How much is a coin purchased for 6,500 pesos worth after 6 years? So how much is a coin purchased for 6,500 pesos worth after 6 years? So we just substitute it here where P is 6,500. So future worth is P 1.1 to the T. So equals 6,500 1.1 to the 6. And again, using your calculator there, it is equal to 11,515 pesos in value. If n is greater than equal to 2 is a positive integer, then 5 to the n may be written as a sum of consecutive odd integers. Do this for the numbers 5 squared, which is 25, 5 cubed, 125, and 5 to the fourth, which is 625. So for 5 square, for 25, if you denote x as the smallest positive uh, odd integer, then the next one is x plus 2, the next one is x plus 3, and the next one would be x plus 4, x plus 6, then x plus 8. So 25 therefore is, so 25 minus quantity 2 plus 4 plus 6 plus 8, 2, 4, 6, 12 plus 8, 20. So 20, 25 minus 20 is 5 divided by 5 because the right side is 5x, so 1. So this is the sum of 1 plus 2 plus 3 plus 4 plus 5. 1 plus 3 plus, sorry, 1 plus 3 plus 5 plus 7 plus 9 consecutive odd integers. So denote the lowest odd integer as x. The next one is x plus 2, x plus 4, x plus x plus 2, x plus 4, x plus 6, x plus 8, so that 25 minus 2 plus quantity 2 plus 4 plus 6 plus 8 is 5, then divided by 5, so 1. So the smallest odd integer is 1, so the next is 3, 5, 7, 9. So that's why it's 25. For the second part, 125 minus the same 2 plus 4 plus 6 plus 8, so 105 divided by 5, 21. So the consecutive odd integers therefore would be 21, 23, 25, 27, 29. So 125 is equal to 21 plus 23 plus 25 plus 27 plus 29. Then 625 minus quantity 2 plus 4 plus 6 plus 8 is 605 divided by 5. So 121. So 625 therefore is 121 plus 123 plus 125 plus 127 plus 129. So that's it. Then for your part, if n is greater equal to 2 is a positive integer, then 4 to the n may be written as a sum of consecutive odd integers. Do this for the numbers 4 square, which is 16, 4 cube, which is 64, and 4 to the fourth, which is 256. So do the same thing as above. So x plus 2, x plus 4, x plus 6. So that's it. So 16 minus quantity 2 plus 4 plus 6 is 4 divided by 4, so 1. So 16 is 1 plus 2 plus 3, sorry, 1 plus 3 plus 5 plus 7. 1 plus 3 is 4 plus 5, 9 plus 7, 16. So that's it. So 4 consecutive odd integers. Then you also do for 64 to 56 just like what I did here. But there are only 4 consecutive odd integers. So to continue, let's have 7 show that quantity 1 to the fifth plus 2 to the fifth, then plus quantity 1 to the 7 plus 2 to the 7 is equal to 2 times 1 plus 2 to the fourth. You may use your calculator right away, or you just evaluate. 1 to the fifth is 1, 2 to the fifth is 32. So that's 33 plus 1 to the 7, which is 1. So 34 plus 2 to the 7. 2 to the 7 is 128. 128 plus 34 is 162. And 162 is 2 times 3 to the 4th. 3 to the 4th is 81 times 2, so 162. 162 equals 162. But in this problem alone, or in this problem, I'll try to show it with sense. But for greater value, for example, 1 to the 5th plus 2 to the 5th plus 3 to the 5th, then plus 1 to the 7 plus 2 to the 7 plus 3 to the 7 is equal to 2 times 1 plus 2 plus 3 quantity to the 4th. That's your part. Then you may use your calculator. It will be very difficult to, or very long to show that uh, the given terms in the left side is equal to that of the right side. But for this case, I'll attempt it so that you can also review factoring. So I'll write it as 1 to the 5th plus 1 to the 7th plus quantity 2 to the 5th plus 2 to the 7th. So if I factor out 1 to the 5th, then we have quantity 1, sorry, 1 to the 4th, then we have quantity 1 plus 1 cube plus 2 to the 4th. For this case, then we have 2 times 2 cube. Since since 1 plus 1 cube is just 2, so 1 to the 4th times 2 plus 2 to the 4th, we factor out 2 for this common factor here. So 2 to the 4th times 2, quantity 1 plus 2 square, which is now this one. Then we factor out 2, which is common to these two terms here. So 1 to the 4th times 2 plus 2 to the 4th times 2, 1 plus 2 square. It is just repeated. Factor out 2, so 1 to the 4th plus 2 to the 4th plus 2 to the 6th. Then we express 2 to the 4th as 2 times 2 cube and 1 to the 4th as 1 times 1 cube. And take note that 2 to the 6 is 2 cube quantity square. So 2 times 1 cube plus 2 times 2 to the 4th plus 2 to the 6th. So again, we write 2 to the 4th as 2 times 2 cube. Well, actually, it is 2 times 1 cube times 2 cube. And 2 to the 6th, we think that it is 2 cube quantity square. So 2 times 1 cube, because 1 times 1 cube is still 1 cube. Then the second one is 2 times 2 cube, and it is the product of 2 times 1 cube, which is still 1 times 2 cube, that's the same. Then 2 to the 6 is imagined as 2 cube quantity square. So that this is a perfect square trinomial if the first term is x cube, the second term is 2 cube, which is y quantity square. If x is 1 cube and y is 2 cube, then this is 2 cube quantity square, or y quantity square. So it is x plus 2xy plus y square, which is a perfect square trinomial. So 2 times 1 cube plus 2 cube quantity square. Then take note that 1 cube plus 2 cube is sum of 2 cubes, and the complete factored form of sum of 2 cubes is we copy the first, which is 1, the second, which is 2, so 1 plus 2, quantity, the square of the first, which is 1 square, then minus the product, which is 1 times 2, then plus the square of the second, which is 2 square. So it is 2 times 1 plus 2, uh, it's like 1 plus 2, then times the other factor. The other factor is square of the first, square of 1, then difference of the 2, which is 1 minus 1 times 2, then the square of the second. Remember, x cubed plus y cubed is x cubed plus y cubed is quantity x plus y. It's like this, x plus y times quantity x squared minus xy plus y squared. So that's the factored form of x cubed plus y cubed, which I did here. And take note that 1 squared minus 1 times 2 is negative 1, plus 2 square is 3. 1 minus 2 is negative 1, plus 4 is 3, and 3 is also 1 plus 2. So we write this as 2, quantity 1 plus 2 times 1 plus 2, then square. Since 1 plus 2 times 1 plus 2 is 1 plus 2 square, so you have 2, 1 plus 2 square, then quantity square. Finally, this is equal to 2 times 1 plus 2 to the fourth. And we have just shown it there. So 2 times 1 plus 2, quantity to the fourth is 2 times 3 to the fourth. 2 times 3 to the fourth. 3 to the fourth is 81 times 2, 162. So 162 equals 162. Actually, you can use your calculator, but I attempted to show it here that the left side is really equal to this value. But for this second problem, then we'll have to calculate it, not anymore to this, because the solution is very lengthy and it is also a challenging one. So we factor out 1 to the fifth. Then we have 1 plus 1 square for 1 to the fifth plus 1 to the 7. For 2 to the fifth plus 2 to the 7, we have 2 to the fifth times 1 plus 2 square. So that's 2 to the fifth plus 2 to the 7. For 3 to the fifth plus 3 to the 7, 3 to the fifth is common. Then we have 3 to the fifth times 1 plus 3 square. Then for 4 to the fifth plus 4 to the 7, 4 to the fifth is common. Then we have times 1 plus 4 square. So 1 to the fifth is 1, and 1 plus 1 square is 2. So this is just 1 times 2. 2 to the fifth is 32, and 1 plus 2 square is 5, so 32 times 5. Then 3 to the fifth is 243, then times 10. 4 to the fifth is 1024, then times 17. So this is 2, this is 160, 2430, and the last one is 17,408. Combining, that is equal to 20,000, and the right side is 2 times 1 plus 2 plus 3 plus 4 to the fourth. This is 10, so 2 times 10 to the fourth. 10 to the fourth is 10,000 times 2, so 20,000. So 20,000 is equal to 20,000 indeed. Then for your part, show that this is just similar to this, and you also do it in this manner here. So show that 2,592 equals 2,592. Use x squared, x to the fourth, x to the 8th, x to the 16, and x to the 32 as factors at most once only in using these factors in writing x to the 55. So 55, if you use the largest as the last, 32 plus 16 is 48. If you use x to the 8, that's 56. That exceeds 55. So we do not use x to the 8. what is missing is x to the 7, and x to the 7 is represented by x times x squared plus x to the 4th. Therefore, x to the 55 is x squared, x to the 4th times x to the 16 times x to the 32. So x to the 55 is x squared times x to the 4th times x to the 16 times x to the 32. Then 11, use x cubed, x to the 9, and x to the 27 at most once each in either the numerator or denominator in expressing x to the 19. So we cannot use in both the numerator and in the denominator. We just use these factors once. So let's study x to the 19. If we use these three powers, it is less than 19, so there should be denominator. If we use x to the 27, that exceeds 19, so if you divide it by x to the 9, that's x to the 18, so it's missing, so we multiply the numerator further by x. So therefore, x to the 19 is x times x to the 27 divided by x to the 9. So to make it x to the 19, because this is x to the 28 minus 9, x to the 28 minus 9 is x to the 19, so that's correct. So for your part, use this, the same as this, then I will not put the answer because you can easily check it. So express x to the 46. Take note that you can only use these different factors once. And the other one, express x to the 33. So that's it for this video, and I hope that you will answer these problems as your part so that little by little you will gain experience, and it's also fun. And I hope that you will gain experience, develop your confidence, and hopefully in the future you will become uh, good engineering students so that you will be successful in your chosen engineering course.